Today we will discuss about time switching. So, a quick recap, what we have done so far is the discussion about space switching and their design. So, now we will see the other dimension of switching, which is the time switching. Before time switching, last class we have already discussed about multiplexing. So, let me go to, so this was where we have been. So, we have been discussing about multiplexing. We have already told T1 framing, which is actually the 24 PCM encoded voice signal is being actually done, the multiplexing is done with word, so this one word interleaving. Okay. So, this is what we have done actually. So, and each word is of 8 bit, whatever the PCM encoded bit numbers that you have. So, each sample is encoded by 8 bits. So, it is generally encoded by 8 bit. So, as you can see over here in this diagram, so you have this is channel 1 followed by channel 2 and like this up to channel 24, and we have also discussed about this framing bit, which is an important criteria actually. So, what we can see, so 24 channels of 8 bit, 192 bit and 1 bit for framing, which is having a sequence. We have already discussed about this also 10 10 10. So, this is that 4 kilohertz signal, which may not be present in any of the other bit pattern of any of those voice signal, because they do not have that frequency 4 kilohertz. So, that is where we do frame synchronization. So, 193 bit per 125 microsecond frame structure. So, this one is 125 microsecond, each one of them is carrying one sample, one PCM encoded sample from every voice signal. Okay. So, that is exactly what is happening. Now, after we have understood this time switching, we will be now talking about this this multiplexing. We will be now talking about this time switching. So, it is actually called, the name is known as TSI or time slot interchange, or it is called time swap. The switching is done in terms of swapping the particular bit location. You know that now this means frame location within a frame, that is the address. So, the first one, first voice is at location 1, second is at location 2 and so on. So, now if we interchange the time means location, probably that will make switching. We will try to see, we will try to appreciate how this actually makes a switching. So, let us try to see. So, what is exactly happening over here? Let us try to draw that. So, this is our multiplexer. Multiplexer has 1, 2 up to let us say C number of voice samples, right. So, this is the multiplexer output. So, this is actually the frame structure that is coming out. So, each one of them is actually having a corresponding voice signal, which is being sampled at Nyquist rate. Each of those samples are means then PCM encoded, and that is exactly coming over here channel 1. Similarly, another voice is coming to channel 2 and so on. Then the multiplexer actually does that frame structure. So, it actually takes each byte from each one of them in a round robin fashion, one after another. Means if there are C is actually 24 for our T1. So, if it is T1 standard, so it depends on standard. So, if you go to this standard, then it is 24, there might be 30 channels. So, there might be other standards also. So, whatever it is, so C number of or 24 number of such PCM encoded 8 bit voice samples will be taken or word will be taken, and then the frame structure will be builded upon after this multiplexer. So, this multiplexer actually gives you that frame structure output with one framing bit and then followed by 1, 2 up to C. Okay. And this is actually your 125 microsecond, and this gets repeated after another. So, if this is a multiplexer, now let us try to see what is a time switching actually. So, let us try to understand that. So, in a switch what happens? I have a box I have this 1 to let us say C number of this one. Let us say I want to create C cross C switch. So, in a space switch what happens? I can connect. So, let us name that 1 dash to C dash. So, any one to anybody I can connect. So, that facility I will have to give somehow. So, here again I have C number of voice signals, okay, which are coming to the multiplexer. So, first any time switch will have a multiplexer at the input, because it has to construct this particular frame structure. So, that is the most important part basically. Okay. So, that is something you will have to do. After that, that particular structure will be talking about time slot interchange, or TSI will be putting. So, basically what it does the swapping. So, let us say I pick some 2 and C, I want to swap. So, basically I want to do a switching between 2 to C dash. So, this switching I want to do. Okay. So, suppose this is the switching I want to do. So, what I will be doing, this TSI will actually swap these things. How it does the swapping, that we will see later, but it intacts the framing bit, and then 1 remains in his place. In the place of 2 it keeps. So, this data it will actually put it over here, and this data it puts it over here. So, C will come over here dot dot dot, and 2 will come over here. Okay. Now, followed by a demultiplexer. Now, demultiplexer what it does, exactly with the frame, synchronized frame, it actually keeps the output according to this sequence. So, once data comes out from here now, but C's data will come out from here, and so on, and from here 2's data will come out. Now, if you just see this structure, it acts like a switch. As you can see, due to this interchanging, so because I have done this interchanging, so due to this interchanging, what is happening, 2's data is coming from this last output. So, that means that switching has been done. So, this is the technique of doing time switching. So, time switching means there should be a swapping of these slots, because slots are the address now. Once I swap the slot, because of this multiplexer and demultiplexer, you will see the effect of switching in the spatial domain. So, basically if you talk about time switch, it is a combination of multiplexer, a time slot interchanger, and a demultiplexer. So, all together it makes a switch. Okay. So, this is another dimension of switching. You will see that this switching you do not require a spatial port or any spatial switch matrix. Over here all you have to do is logically swap the location of the bits or bytes, let us say, in the sequence of frame. So, whichever sequence they are in the frame, you just swap that, and if you do that, what will be happening, that is the logic you will be always having. So, basically what you do, every frame you will be swapping these things. So, that is the logic you will have to keep it. So, every frame you have the frame synchronization. So, you know from this bit. So, this is the starting of the frame, and then from that synchronization you will keep on doing this swapping. So, every frame you will be doing same swapping as long as this particular switching is required. If you change this, so later on after sometimes probably after let us say 10,000 frames, you need to change this. So, now you want to swap between 2 and 3, then what you will do? So, from then onwards you will change this particular configuration, you will swap between 2 and 3 instead of 2 and C. Immediately the switching will be done between port 2 and port 3. So, this is a phenomena that is termed as time switching. Okay. Now, let us go a little bit deeper into this TSI unit. So, time slot interchange, let us try to understand that part. So, TSI unit. Okay. So, this is particularly a TSI unit. In that TSI unit, as you can see, you have this let us say 1 to C number of elements, you have a multiplexer like we have discussed. This is the whole unit of time slot interchange, this whole thing, okay. And this is followed by demultiplexer, and then you have 1 to C that is going out, or you can call it 1 dash to C dash. So, suppose now you want to switch between I and j location. So, jth location and ith location. So, you want to swap this. This is what you want to do. So, basically what time switch does is something like this, or time slot interchange. What it does, whatever data these frames are coming, because you know the synchronization. So, basically you read byte by byte after the synchronization is being done. So, you know one frame. So, take that entire one frame data and byte by byte data you read. Okay. After reading it, you actually store in a data storage. So, as you can see, that data storage facility has basically storage from starting from 1 to C. That many storage locations are there. Each one of this data store can actually store a byte. So, if it is PCM encoded 8 bit, then it can store 8 bit. If your encoder is different, let us say 10 bit or any other things, then that data store length also should be of that many bits. So, over here it is 8 bit. And how many storage places are there? C storage places are there. Now, what is happening? Suppose you want to, there are two ways of doing these things. So, let us talk about one of them. So, one of them is when you are writing it into the data storage. So, basically from this side, from this left hand side, you are actually writing it into the data storage. Okay. And on the other side, you will be actually reading it from there. Okay. So, there are two operations actually, eventually you are writing and then eventually you are reading. So, when you are writing, what you have to do is all those bytes that are there, you can sequentially write them. That means, the first one, this first one you can write it over here in the first location, second one you can write it in the second location, and so on up to C, you can do that. Okay. So, you can also do other things. So, initially let us think about that is what I will be doing. So, I will be storing them sequentially, but while reading I need to do swapping. So, suppose I and j I want to swap. So, basically what I will do, I also have a memory or control bit. So, this is the control bits. What I do, again I will be having 1 to C number of specification where the control information will be there. Okay. In that 1 to C, suppose I to j I want to swap, that means ith data should go to jth data and jth data should come to ith data. So, therefore, in the control what I will write, in the ith location I will actually store the value j, okay, and in the jth location I will store the value I. What does this signifies? So, while reading I will, means while this from this one, when I am reading them to the multiplexer, now what I will do, I first do not read it from here, I first go to the control location. So, control location in the 1th, this one, whatever is stored over here, that data I will be reading. So, I do a random reading over here, guided by of course the control bit. So, this control buffer, whatever he is guiding me, accordingly I read it. Okay. So, if I go to, suppose the ith data has to be fetched. So, in the ith location what I need to put? So, in the ith location I first see which data I have to fetch. So, jth data. So, I go to the jth location, whatever data is stored, that I put in the ith location. So, this is the ith location and I put the jth data. And similarly, when I have to read the jth one, first I go to jth control bit or control information, I see ith data has to read, has to be read. So, basically I go to the ith location of this data storage and that I read. Immediately what happens? I will get this swapping. Whatever swapping I want, all these things can be stored over here in the memory location. Okay. So, I can do simultaneously swapping multiple things, I to j, I can in between 1 to C suppose I want to do. So, over here I will store C and over here I will store 1. So, accordingly he will read. Whenever he sees the first data, he sees which one to be read, the Cth one. So, he will fetch this data. So, over here the Cth data will be stored. Okay. And similarly, when he goes to the cth location, he will actually fetch the first data. So, accordingly C and 1 also will be fetched, and immediately you will see after demultiplexer that switching will be, corresponding switching will be done. So, this is how switching, time switching is being actually understood, okay, or realized in a particular circuit. So, as you can see, it is a digital circuit. You have just two storage, one is this data storage and one is this control storage. Okay. Now, if you try to ask that how much storage is overall required. So, over here as you can see, I do not actually need any kind of switching element. So, switching elements are not required, it is just through logic and memory reading and memory writing I am capable of doing the switching. So, it is about how much storage is required. So, as you can see, if I have C things multiplex. So, if I wish to actually construct now C cross C switch, okay, and each one of them is actually multiplexed with a 8-bit PCM encoded voice signal. So, if that is happening, then how much storage for data I require? So, C places of 8-bit. So, C into 8, that many bits are required, okay, for data storage. How much or how many number of bits are required for control? So, how many control locations are there? That is still C. How many bits per this one, per control information? So, now as you can see, what are the information I will have to store maximum up to C. So, basically 1, 2 up to C. How they can be represented by binary bits? So, that should be log 2 C, this many number of bits are required to represent all of them. So, basically each one of them will be requiring that many bits. Of course, if log 2 C is not an integer, I will have to take the ceiling of that. Okay. So, let me generally C is taken, so that it's an, if it is an integer. So, I can put it as log 2 C. Okay. So, this many bits are required for my data, means overall control realization or overall time slot interchange realization. This is for the data storage and this is for the control. Okay. As you can see, if I represent a different PCM encoder, then 8 will be changed. If I represent a different number of multiplexed data stream, then C will be changed, and accordingly my data requirement will be changed. Okay. I hope this is understood. So, now as we were discussing, so we can have this time switch realization or time switch can be realized in two different ways. One is, as we have said, that we will do sequential write and random read, the one I was doing. So, earlier in the earlier demonstration what we have done. So, you are reading them sequentially. So, one after another you are reading them, and then while writing you are writing them sequentially. So, sequential write, while reading them from the storage, data storage, then you are reading them randomly according to your buffer location. You can also do the reverse. What you can do, while storing them, you actually store them from the memory, this control requirement. So, you store them accordingly, and then while reading you do a sequential read. So, that will be random write and sequential read, both of them are okay. Okay. So, either of them you can implement. Okay. So, this is two ways of implementing this time slot interchange, this TSI. Okay. So, we have already understood this part. Now, this is very good, because earlier we were actually seeing that this switching element, that's a major probably cost consuming element, and that was giving a stray capacitance effect and all those things we wanted to get rid of. We were trying to do space switch which were sharing, so that number of switching elements were reduced, but now we have got a time switch which is not requiring any of those elements. So, it is just pure digital logic, reading to the memory, writing into the memory, means reading from the memory. This is all that is required. But is that all rosy? There are no free lunches, right? in engineering always if you achieve something, you must be paying somewhere. So, where exactly we are now paying? Let us try to understand that part. What is happening? As you can see over here in time switching. So, whenever you are switching them, so basically a frame is coming to you of duration 125 microsecond. Okay. So, a full frame is coming to you. Now, what you have to do for switching? First, you will have to store the entire frame, because each of this byte location has to be stored in the data storage. Then only you can do a switching operation, or while storing, if you do a random write, then while doing the storing, whatever it is, you have to store them, you can do the switching, but after that you will have to read from that memory. So, whatever you do, as you can see, this frame will be only delivered after 125 microsecond, because for the entire 125 microsecond you will be storing them, and then next 125 microsecond you will be actually putting them into the channel, okay, or putting them into the demultiplexer. So, that means every time switch eventually will always give you 125 microsecond delay. That is always that is something you will be always seeing. Okay. So, this is inevitable, you can't actually get rid of this particular part. So, this kind of TSI element you put, as many such element you will be putting, every one of them will be giving you 125 microsecond delay. So, now earlier your space switch, which was not giving you any delay, it was very nicely designed, it was of course bulky, it was costly, and it was probably giving you all those stray capacitance effect. But now we have designed a switch which is good, gets rid of all these things, but now it introduces delay. So, now how far you can withstand delay, that is up to you. Okay. Second thing, is there a limitation? Can I start putting as many, suppose this multiplexer duration I can actually make it very big. Okay. So, or this multiplexer size I can make it very big, or the frames duration or within the frame how many such things will be there. So, that is the number C, I can make it very big, and that might increase my switch dimension. But is it possible that infinitely I actually increase this dimension? Is it possible at all? So, this is something next we will have to see, that is there a restriction on this particular number or value C. Let us try to understand that part. Let us try to see within this 125 microsecond how many things we are doing actually. So, basically what we are doing, at the input we are writing to the memory. So, that is one operation. So, byte by byte we are writing. So, if there are C bytes, then C number of writing operation you will have to do, and at the same time within that 125 microsecond you will also, after that you will have to read from the memory. So, another C read operation you will have to do. So, overall 2 C operation you will have to do within this 125 microsecond. Every 125 microsecond you will eventually have to do this many operation. So, therefore, there is a speed restriction. If you increase C, your speed of reading and writing has to be very high. Okay. So, memory writing and memory reading, that speed has to be very high, and there is a restriction, hardware restriction of that. So, therefore, as you can see, every 125 microsecond I will have to do 2 C operation. Okay. So, if you see that this 2 C divided by 125 microseconds, so that many operation per second you will actually have to perform, and that should be the speed of your memory read and write. If you increase C, of course, it will hit the hardware restriction and you will not be able to go beyond some C value. So, that is another restriction that is coming over the time switch. So, we have now seen that there are 2 restrictions of this time switching. Okay. So, what are these 2 restrictions? So, one is that whatever you do, you will be having always 125 microsecond delay, that is one of the restriction. Second restriction is there is a speed limit, you cannot indefinitely increase the value C to make the switch dimension very high, because there is a hardware restriction on that. So, we come back to these again, So, we could now see that we have designed a time switch, we have designed a space switch. Space switch has some typical advantage, time switch has some typical advantage. Now, what we wish to do, we want to actually add the virtue of these two or the advantage of these two. Can we do that? Can we take the advantage from time switch as well as space switch while designing an overall switch? So, that will be the discussion of our next class, where we will try to actually combine these two switch, time and space switch, to come up with a better design. So, this is something which we will be discussing next. Okay. Thank you.